Hey everyone, welcome back. We're talking about in behavior of function graphs. Man, do we like functions? In behavior is a horizontal question that is answered vertically. Don't get that confused with this other concept, which we're not studying today, intervals of increase and decrease. It is a vertical question answered horizontally. Again, let's do one thing at a time, but there is that other thing out there. What does in behavior ask? Well, you can answer it two ways, with numbers and with graphs. We're not doing numbers today, we're doing graphs. So as the graph goes way to the right, what does it do vertically? And the same thing for left in behavior. We're not doing numbers. As it goes way to the left, what does it do vertically? Here is a man named Steve, and you might be saying, Steve, who is Steve? Steve is our imagination, and we're going to use Steve, our imagination, to help us. All right, right in behavior. We want to take Steve as far to the right as we can possibly imagine. So if we have to imagine more space, we imagine more space, and we just keep going to the right and to the right and to the right, right forever. And the same thing for the left in behavior. We go as far left as we can possibly imagine. We create more space mentally. Keep in mind, in behavior is a horizontal question answered vertically. There are 5 observations that we're going to make. One observation is up. Number 2, down. Number 3, it's going to zigzag like sine or cosine, and then it's going to flatten out an asymptote. And the last option is it's just not there. Well, if the option is up, the result is going to be infinity. Well, it follows that if the option is down or the observation is down, the result is negative infinity. If it zigzags like sine or cosine, we're going to say it does not exist. We'll talk about that. If it flattens out at an asymptote, the result is a constant where the asymptote hits the y-axis. And if it's not there, what do you think? Doesn't exist. Well, let's deal with these concepts one at a time. We can't do 5 things at a time. Come on. Here are some graphs that have a right end that's going up, and their end behavior is infinity. Even this one, crazy integer function. And that's pretty easy, but let's investigate anyway. Let's take our imagination as far to the right as we can possibly imagine and ask 2 questions. Number 1, is the graph still above him? Yes, it is going to come over here. Maybe not like that, but it is going to be above him. And number 2, if we were to go more to the right, more to the right, more to the right, would it be even higher? The answer is yes. And the end behavior of this graph is infinity. Let's do the left side. Left end up, 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 up. Hey, that's a square root function. And let's ask the same questions. Let's move our imagination far left first. Let's ask, is the graph still above him? Yes. If we were to go more to the left, does it go even higher? The answer to that is yes. And the left end behavior is infinity. An observation of down is just as easy as an observation of up, except it's negative infinity. Let's look at the right end of these functions, and they are down, negative infinity. But let's still use our imagination and ask some questions. Number 1, is the graph still below him? Clearly, yes. Number 2, if more to the right, would the graph be even lower? And the answer to that is yes. So the right end behavior is negative infinity. Let's look at the left end down being negative infinity. All of these are going down, even this one in a discontinuous way, the old integer function, and let's investigate it. Take the imagination far to the left. Ask, is the graph still below him? Clearly, yes. It's going to be doing something like this. So the answer is yes. And if more to the left, if we were to take Steve more to the left, would it be even lower? The answer is yes. Therefore, the left end behavior of that stair function is negative infinity. I have to tell you, I've been playing this game a long time, and when I ask about end behavior, lots of times I get either infinity or negative infinity as a result. But that's not always the case. If a function zigzags like this, that's either sine or cosine one way or another, there is no end behavior. But let's investigate it as infinity. Let's get rid of that and say, well, what if it's infinity? Well, let's get Steve to go way over here to the right and ask the question, is the graph still above him? Yes. If more to the right, does it go even higher? Well, it's going to do this. So the answer is yes and no. Well, that no makes it bad as far as it being infinity. The answer is does not exist, and we will abbreviate that D and E from time to time. Option 4, flattening out at an asymptote where the result is a constant. Remember, lots of times we say infinity or negative infinity. It's like a 50-50 guess. Let's investigate this as if it were going to be negative infinity. Here we have a function that we could make the argument goes down forever. Remember, that asymptote comes out here with it. Let's take our imagination as far to the right as we possibly can. Let's get rid of that and say, okay, it's going down, so it's got to be negative infinity. Let's ask those questions. Is the graph still below our imagination? Clearly, yes. And here's the rub. If more to the right, does it go even lower? The answer to that is no. You might say, I don't know about that. It's kind of like asking the question, is 0.9 repeating equal to 1? What is the answer to that? Yes, it is equal to 1. What that means for something like this is the function never gets lower than 1, and it's so close to 1, then we say it's 1, and we get the number 1 by where the asymptote hits the y-axis there. Here are two functions that flatten out as they go to the right. We already did this one. It's 1. This one flattens out at the x-axis, so its right-end behavior is 0, a constant. Here are two functions that flatten out as they go to the left. This one's left-end behavior is -2 because the asymptote hits the y-axis at -2. This one flattens out at the x-axis as it goes to the left, so its left-end behavior is 0. Option 5, if the graph isn't there, then the end behavior doesn't exist. That seems to make sense. Let's investigate and use our imagination to do it. Here we have two functions that end as they go to the right in two distinct ways. Let's look at one of them here, the square root function, and let's move our imagination way over here. Let's ask ourselves, is the graph still above him? The answer to that is no, because it ended. Let's don't go any further, and let's say that the end behavior does not exist. Let's do that with the natural log function because we probably need to do that. Let's move our imagination over. Let's ask ourselves, is the graph still above him? No, therefore it does not exist. But you might say, well, the graph is coming down like this, and it does do something forever. It goes down forever, and that is a bounded below question, but we're not studying that right now, so let's not go there. These two graphs end as they go to the left, so their left end behavior does not exist, D and E. This one right here has an asymptote. It doesn't cross it, and so its left end behavior is D and E, does not exist. This information will be in a PDF at Google Classroom, and it's all the information that we just discussed. Let's do some problems before we go. This is math class, and we should do some. At Socrative, if I ask for number 1, that's what I mean right there. There are two answers. Pause the video and see if you can figure that out. Part of this is knowing what functions we have. This is e to the x that got reflected. We have an asymptote right there. So the left end behavior is 2. It's flattening out. And the right end behavior is down or negative infinity. These are fun. Number 2, see if you can get that right. As it goes left, it's going up. So that would be infinity, and as it goes to the right, it's going down. It's negative infinity. Number 3, the staircase function, the integer function. The left end behavior is negative infinity, and the right end behavior is infinity. You have to put both of those at Socrative. I'll ask that. Number 4, hey, that's old y equal x squared that got transformed one way or another. The left and right end behaviors are infinity. That does occur a lot. Sine or cosine one way or another, zigzagging. We saw that the end behaviors don't exist there. Number 6, this is the natural log function that has an asymptote right here. The left end does go up forever, but the right end does not exist because it doesn't go past the asymptote. Part of this is knowing the functions that we are studying. That's just the parent function e to the x. It looks like the left end behavior is 0 because it's flattening out at the x-axis, and the right end behavior is infinity. I believe this is the last problem, number 8. That's the square root function that got reflected. As it goes to the left, it's going up, and as it goes to the right, it gets chopped off right there, and it doesn't go right forever, so it's D and E. Guys, I had a whole lot of fun today talking to you about left and right end behaviors. Hey, the answer isn't always infinity or negative infinity.